Today in the workshop, we're working with a human presence sensor. You'll see how the LD2410 works and how we can use it to detect human beings. We'll also use our sensor with Windows, Android, and an ESP32. We're sensing life forms today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we're going to be working with an interesting sensor, something called the Human Presence Sensor. And sensing humans is a pretty popular thing to do. I mean, there's over 8 billion of them on the planet, and sensing where they are can be very useful for a number of applications. You can use it for security in case human beings are getting into places where they shouldn't, for safety for pretty well the same reasons. You could also use it with automation within your home control. If you have a smart home and you want to sense whether people have entered into the room and set a sequence of events off, this is the type of device you're going to use. Now, today the sensor we're going to be using is called an LD2410, and it's a very popular human presence sensor. We've sensed human beings before with infrared sensors, but this is a microwave-based sensor. And this sensor can be used all on its own. It can be used with a Windows application, it can be used with Bluetooth, and it can also be used with a microcontroller with an ESP32. And so we're going to use it in all of those different fashions. So let's go and take a look at the LD2410 Human Presence Sensor. The LD2410C is a microwave-based human presence detector. The device is capable of detecting an individual moving or stationary person. It operates with a 60-degree detection angle. The LD2410C utilizes FMCW Radar technology to perform detection. FMCW is an abbreviation for Frequency Modulated Continuous Wave. The sensor works by sweeping its carrier frequency from 24 to 24.25 GHz. This wave is reflected back from the target to the sensor. When it arrives at the sensor, the frequency of the incoming wave is compared to the outgoing one. As the frequency of the outgoing one is continuously changing, these two frequencies will not be the same. The difference between the frequencies is called the beat frequency. The beat frequency is directly proportional to distance, so that frequency can be used to make a distance measurement. A change in the beat frequency can indicate movement of the target. Within the LD2410C, distance detection is divided up into 9 gates. Each gate represents a fixed range interval. The default spacing between gates is 0.75 meters. You can adjust the motion sensitivity for each gate individually. By dividing distance up into gates, the LD2410C can monitor a specific area. For example, if you're monitoring your desk, you might only monitor gate 0 or 1 if you're close to the sensor. You can also ignore specific areas. For example, an open doorway leading to a trafficked hall could be ignored. Dividing the detection into gates is also a method of eliminating false positives. There are two methods of mounting the LD2410C Human Presence Sensor. In a ceiling mount arrangement, the LD2410C will project a 60-degree beam. Any persons walking within this beam will be detected. The sensor can also be wall-mounted and will detect any humans within a distance of 5 meters. The LD2410C module has 5 pins. The first 2 pins are the transmit and receive used for the UART. The UART has a default speed of 256 kilobaud. It should be noted that the UART pins work on a 3.3 volt logic level and are not 5 volt tolerant. The third pin is the digital output. This pin will go high when the sensor detects a person within a certain preset detection range. You can adjust this range on the sensor. The last 2 pins are the ground and VCC, or power connections. The sensor operates on a power supply of 5 to 12 volts, and the manufacturer recommends using a 5 volt supply. It has an internal regulator to step this voltage down to 3.3 volts. The LD2410C is the third member of a family of microwave human presence sensors. The LD2410 and 2410B look the same. The LD2410 can only communicate through its serial UART. The LD2410B and 2410C also have Bluetooth capabilities. The LD2410 and 2410B are not breadboard friendly, as their pins are spaced too close together. Most of these devices come with an adapter cable, and if you are going to use one, make certain you get one of the cables. The LD2410C has improved performance over its two predecessors and is recommended for new designs. If you're using ESP Home, the add-on component, the Home Assistant that allows you to interface with ESP32 devices, it supports the LD2410C directly. So now let's take a look at the LD2410C Human Presence Detector. And here we are with the LD2410C Human Presence Detector, and as you can see, it's a pretty tiny little unit. To give you a rough idea of its size, I've got an Arduino Nano ESP32 that I'll just place over here, and so I think most of us know the size of the Nano. You can judge the size of the sensor with this. Now, it's very easy to use. There's a connection on the top with the transmit and receive for the UART, the GPIO output pin, the individual output that will go high when a preset distance has been detected with a human in it, and then ground and power. Now, in terms of ground and power, as I mentioned earlier, you can use anywhere from 5 to 12 volts. The manufacturer prefers you go closer to 5 because there'll be less dissipation on the internal voltage regulator. I'm going to be using a 9-volt battery. It falls within that range, and it's a very easy thing to do on the breadboard. But for a permanent installation, batteries aren't really a great idea. This sensor takes quite a bit of current, and you're going to want to line power this thing. Now, one thing that would be an excellent way of powering it would be USB power, and I did a video a while ago on using USB PD with a USB-C connector, and this would be a great way of creating a power supply for the LD2410. But however you power it, this is a great human presence sensor, and so let's go and hook it up and see how we use it. So now that we're familiar with the LD2410, we can begin using it. And one great way to get started with this human presence sensor is to use a Microsoft Windows-based utility, the LD2410-Tool, which is available from the manufacturer. And you'll find a link to the tool in the article that accompanies this video on the DroneBotWorkshop.com website. Using this tool, we can not only make use of the sensor, we can also configure the sensor. Of course, the sensor needs to be connected to a Windows computer, and it doesn't have a USB port, but we can just use something like an FTDI adapter to connect it up to our computer. So let's go and take a look at how we wire that up and how we use the LD2410 tool under Microsoft Windows. For this simple hookup, we're going to need the LD2410C Microwave Human Presence Detector, an FTDI adapter, and this needs to be a 3.3 volt FTDI. Many FTDI adapters have a switch that allows you to select 5 or 3.3 volts. Some of them have a jumper. Make certain that yours gives a 3.3 volt logic output. We'll also need a power supply for the LD2410C. This can be anything between 5 and 12 volts. We'll begin by connecting the transmit line of the LD2410C to the receive pin on the FTDI adapter. Conversely, we'll connect the receive line on the LD2410C to the transmit side of the FTDI. The output pin of the LD2410C is not connected to anything. The sensor's ground will be connected to the FTDI ground, and the VCC on the LD2410C will be connected to the positive output of the power supply. Make certain that you also connect the negative output of the power supply to the ground. And this completes the wiring. Now hook a USB cable up to this, connect the other end to your Windows computer, and we'll test out the LD2410C. Now, in order to use the Windows LD2410 Tool GUI, you will of course have to download and install it. It's a self-running exe file, so there's no actual installation. And to download it, Highlink, the manufacturer of the sensor, has actually chosen an interesting method. They're doing it off of a Google Drive. And so this is basically the Google Drive page, which has the tool. It's over here. You can download it just with this little link here, and then open it up. As I said, there's no installation necessary. necessary. It's just an exe file that'll run by itself. When you're here, you can also grab the user manual as a PDF and a serial communication protocol manual if that's of interest to you as well. If you need the link to this page, just check out the article that accompanies this video on the DroneBotWorkshop.com website. Once you've downloaded it, just unzip the file and run the exe, and you'll be running the LD2410 tool. Alright, so this is how I've connected everything up. As you can see, I'm using a 9-volt battery as my power supply, and otherwise I have my FTDI adapter connected to my computer and the LD2410, which is kind of aiming away from me right now, but it still should be able to pick me up from its position on the workbench. Now, if we go over to the GUI tool, you will see the screen that we have, and the first thing you need to do is select the port, and so mine ended up being on COM 8. If you don't see your COM port, hit the refresh and it'll probably come up. I've already hit the connect button over here. It turns into a disconnect button, and the baud rate is the default 256 kilobaud. I've put it not in engineering mode at the moment. We'll see that in a minute. And I haven't hit the start button because I wanted to show you the parameters down here. They have a series of parameters you can configure. Now, RG indicates the gates, and so they're saying the maximum moving RG gate is number 8 and motionless is number 8. Now, if you want to have your sensor not be sensitive to things that far away, you can reduce this number and choose another gate. Another thing you can do here is the sensitivity button, and if I click onto that, you will see that it gives you the sensitivity for each individual gate, and you can adjust that if you wish, and then you can set that inside your unit. So you can configure the unit for this as well. We can go into engineering mode over here and hit start. And we start seeing some data, and this data is the distance to me, which it sees as mostly a motionless but sometimes moving target when I move my mouth. Now, it's really not pointing at me, so I'll just move it around, and as you can see, the distance does change. Again, the moving and motionless, it's very hard to stay motionless in front of this thing, but if I'll walk away a little bit from it right now if I can. Oops, I've got a 0 centimeter over here. Oh, that's because it's going for moving. Okay, let's just walk away. And if I walk back, you can see the distance changes, so it is definitely detecting me. And with this utility, you can fine-tune all the parameters to make the detection just perfect. So this is a useful utility for running under Windows. One last thing I wanted to mention, on one of the computers, this one as a matter of fact, I wasn't initially able to run this. I got a message about a missing DLL. It worked on my other Windows computers. I got this one working just by installing the Microsoft Visual Studio 2010 package onto Windows. And so if you get that error, just go and look for the Visual Studio 2010 runtime package, install it on your Windows computer, and it seemed to fix mine. It'll probably fix yours. Now, there's another tool available for working with the LD2410, and this tool is an online tool. It's the LD2410 Configurator, and it has an advantage in that it'll work not only under Windows, but also under Linux and Mac OS as well. It's very easy. At the beginning, your connection options, you can display the advanced ones, but that's just basically the baud rate, which is set to the 256 kilobaud, which is the standard for these. Now, I'm using the same setup with the LD2410 as I did with the Windows utility, so nothing's changed here. I'm going to select the port to connect, and it shows the two ports. COM 8 is my port, so I'm going to select that. I'll connect it, and here we go. And this screen actually in many ways is even easier to understand. It gives you all of the gates. I'll scroll it down over here so you can see that it has all of the 9 gates and the values you're getting, and you can set the sensitivity for all of the different gates over here, and that's great. You can configure that as well as do the detection of stationary or moving items. You can even see the raw data over here. So this is another utility for working with the LD2410. Might even be an easier one to use than the previous one that we looked at, and just another way of configuring the device to make it perfect for your application. The HLKRadar Tool app is another method of using the LD2410 Human Presence Sensor. This app is available for both Android and for Apple iOS devices, and it works via Bluetooth. So let's go and take a look at this app and how we would use it with the LD2410. In order to communicate with the LD2410 using Bluetooth, we'll be using the HLKRadar Tool app, which is available for both Android and for iOS devices. Now here's the Android one in the Google Play Store, so this is just what you need. Just install this onto one or more of your devices, and you'll be ready to talk to your LD2410. Now, since I'm just using Bluetooth, I don't need to make any connections to the LD2410 except for power. And so I'm just powering off of a 9-volt battery to the ground in VCC. And as I mentioned earlier, it's not the best permanent power supply, but for testing, it's really good. And I've got the HLK app running right now on my phone, and it has detected a LD2410 sensor. Now, if there was more than one sensor, it would be seeing more than one, but since this is my only one, I can click onto it. And there we go. And as you see, this is very, very similar to the utilities we've already seen. It shows you a number of different things about the LD2410, moving and static targets. I can move the sensor around a little bit to get a few readings. And of course, it's reading me, and I'm pretty close to it. Just back off a little bit from it. And it shows me backed off. So it's basically the same kind of information that you would get with the other utilities, but of course the advantage of this is that it uses Bluetooth, so you don't need to make any connection to the sensor. If you're setting a number of these sensors up, this could actually be a very useful thing to have in order to test and set up a bunch of sensors without having to actually connect to them. So this is just another method that you can configure and view the data from the LD2410 Human Presence Sensor. So now that we've used the LD2410 with both Windows and Bluetooth, it's time to move on to a microcontroller, and we are going to be using an ESP32 with this. Now there are a couple of ways you could use an LD2410 with an ESP32. If you're using Home Assistant and you have the ESP Home add-on, you can connect the device to an ESP32 and use ESP Home to interface directly with it. However, today we aren't going to be doing that. We're going to be using the Arduino IDE and a really full-featured library called the My LD2410 library. So let's go and take a look at that library and how we hook everything up to an ESP32. Now, the My LD2410 library for the Arduino IDE is an excellent method of using the LD2410 with a number of common microcontrollers, including the ESP32. Here it is on GitHub, and on GitHub they've got a great introduction to the library. They show you the pinouts of the 2410C and B, which both can be used with this library. And they've got pinouts down here for some very common microcontrollers, including the one that I'm using over here. They'll tell you whether you're using the serial 1 or serial 0 UART, and there's even a couple of examples over here, and the library itself comes with a number of examples. It also comes with a great definition of all the different classes, a class reference, and so basically between this and the example codes included with the library, you can pretty well program anything you wish with the LD2410. You can get readings from it, and you can also configure the device using this library. Now, you can install the library from the GitHub files if you wish, but by far the easiest way of doing it is just to go into your Arduino IDE in the library manager and type in My LD2410, and you'll find it over here, and you can just hit the button to install that. Once you install that, there'll be a number of example sketches that'll be added to your IDE, and we're going to check one of those ones out right now. For our experiment, we're going to require, of course, the LD2410C Human Presence Detector and an ESP32. I'm using an ESP32 S3 dev kit for my experiment, but just about any ESP32 could do. If you don't have the same GPIO pins that I'm using, you could substitute other GPIO pins and just change that in code. We'll begin by connecting the transmit line from the LD2410C to GPIO pin 18 on the ESP32. The receive line on the Human Presence Sensor will be connected to GPIO pin 17. There's no connection to the output pin from the sensor, and the sensor's ground pin will be connected to the ESP32 ground. Finally, the VCC pin on the LD2410C will be connected to the 5-volt output from the ESP32. And that's it for the wiring. Now let's go and take a look at some code we can use to work with our human presence sensor. Now, one of the example sketches included with the My LD2410 library is the sensor data sketch, and what it does is it basically exposes all those methods you just saw and displays them on the serial monitor. And there's a lot of instructions in here about how you can put it into enhanced mode or debug mode. I'd advise you to read that and play around with it. They also, at the very beginning, go through a number of different common microcontrollers and determine the pinout. So if you're using one of these microcontrollers, it'll run without modification. Otherwise, you're going to probably have to define the receive and transmit pin if you're using a different microcontroller or a different pinout. Now, down over here, they have a function called print data, and print data is really the heart of this sketch, because basically they're just using a whole bunch of the different methods they have, like the sensor status screen, sensor detected distance, sensor moving target detected, moving target signal, etc. All of these are being read from the library, so they're basically just being taken and formatted and printed to the screen, and that really is the bulk of the program. The setup just basically sets up the sensor, and in the loop, we just go and call that print data statement at the end of it over here, and we continue to go back and print data from the UART. So it's a sketch that basically just exposes every method of the library, so it's a really good one. So let's load it up to our ESP32 dev module and take a look at it running. And so here's our demonstration of the ESP32 with the LD2410, and I've got it hooked to the ESP32. It's just sitting on my workbench, so it's actually picking up me because I'm right beside it, but of course it's aimed at the ceiling, not necessarily at me. Now, if we look at the serial monitor, we can see both moving and stationary because just the small movements I'm making are being considered to be movements. Now, if I move this around, I should be able to change those readings a bit. I move me around, yeah, and you can see that the number of centimeters is changing for the moving and stationary. Another interesting thing is it displays the light level, as there's a light sensor on here. So if I block the thing with my hand, you can see the light level drop down to next to nothing. I'll remove it again. And so it basically does as advertised. It's reading the data off the LD2410 and bringing it out so it's available to the ESP32. And of course, this means that we can write all sorts of code around the LD2410 Human Presence Sensor using this great library. And there you have it, the LD2410 Human Presence Sensor. A really sophisticated device in a tiny, inexpensive package that I think you'll find a lot of use for, either in your home automation applications, security applications, or anywhere else where you can think it can be useful to find out if there's any human beings lurking about. Now, if you want some more information about the LD2410, or if you want to grab the code I used with the ESP32, or the links to all the apps that I used today, you'll find everything in the article on the DroneBotWorkshop.com website, and there's a link right below this video to that article. When you're on the website, if you haven't yet, please consider subscribing to my newsletter. No, it is not a sales letter, just a way of letting you know what's going on here in the workshop, and it's of course free to subscribe. It's also free to join the DroneBot Workshop forums, where you can discuss the LD2410 and all sorts of other components with other like-minded individuals. And the forum, as I said, is also free to join. There's information below the video on that. And if you still haven't subscribed to the YouTube channel, this might be the day to do that. Subscribing is very easy. All you need to do is click on that red subscribe button, and if you also hit the bell notification, you will get notified every time that I make a new video, assuming of course that you've enabled notifications on your web browser. So until we meet the next time, please take good care of yourself, stay safe out there, and I'll see you soon here in the DroneBot Workshop. Goodbye for now.